Hello everyone. Today we are going to see how many non-destructive testings are there. As we have seen earlier, few destructive testings like impact test, bend test, nick break test, different tests were there. So in non-destructive testing, we will go through its basic introduction, then its working principle. So the name itself says non-destructive means we don't have to destruct any part. For testing, we don't have to break any part. So the different types of NDT, that means non-destructive testings, are first visual check, then paraffin and white wash test, then magnetic particle test, then hydraulic test, stethoscopic test, air pressure test, radiography test, ultrasonic test, eddy current test, and dye penetrant test. So we will go through all these 10 tests. So let's go on the first point, visual check. Visual check is nothing but the inspection done by a skilled worker by his naked eyes. So basic 3 points are considered over there. First is physical dimension of the weld, right? Second one is penetration weld metal, and third is surface defects. So physical dimensions of the weld is nothing but, let's say the setup of this welding butt joint is over here. So the physical dimension of the weld means the length of this object, the length of this particular V groove. The V groove is made over here, which is having a 60-degree angle. You can see one gap is there, which is of having 2 mm. Right, so this kind of things are used to be checked before doing welding. Then penetration weld metal. Penetration weld metal means the weld metal which is going to be deposited over here by melting the electrode. It should penetrate up to its crater area. Crater area means the lower area. Then point number 3, surface defects. So the place where we are going to weld, that place should be neat and cleaned enough. So this thing is usually checked by a worker. Also 3 things are there. First is before welding, second one is during the welding, and third one is after welding. Now before welding means the surface is checked for contaminations like dust, oil, grease, and scale. The cut edges are checked carefully for presence of burns. So before doing welding, the gap, the groove surface, all these surfaces are required to be cleaned enough. Now next, during the welding. Now welding process parameters, welding consumables, preheat, interpass temperatures, placement of weld run, distortion control, heating temperature and time, etc. These different things are checked during the welding. How many number of passes are going to be done? After each and every pass, we have to clean the welding. That kind of things are considered in this second step. Now third is after welding. After welding, we have to check the welded joint for accuracy as per the drawing. We have to check different defects like undercuts, spatters, roughness, pits, left without weld metal filling, and overlap. So this is nothing but the basic welding inspection which is required to be done by all the welders. Okay, so first topic is completed, visual check. Now let's move on to the next point, paraffin and white wash test. This test is basically used to find the surface cracks. The cracks or defects which is on the surface of the job, it can be detected by this particular test. So what is done in this particular test? The weld is first painted with paraffin and then dried. So you can see now at number 1, this is our job. Crack is visible over here. So first we have to apply a paraffin which is of white color liquid, and we have to let it to be dried over there. Then next you can see point number 2 is here. Then white wash is applied and it is also allowed there to be dried. So what will happen if cracks are present on the surface, then the oil lines of this particular paraffin will be developed over here. So we can easily identify crack over here. Okay, so this was the very simple test. Now third one, magnetic particle test. So magnetic particle test is used to find surface cracks as well as subsurface cracks up to some level, maybe up to 10 mm to 15 mm. We cannot go more than that. It cannot detect defects beyond that surface. So the crack is basically found out by attracting iron oxide by magnetic system in this test. So let's see the principle of that. Let's say I'm having a magnet over here which is having north pole and south pole. If this bar is broken in two parts from the center, then two parts or two bars, or we can say two magnets with magnetic poles on each end of each piece. If the magnet is just cracked but not broken, just like this, if magnet is just cracked but not broken, it is not broken in two parts, it's just cracked up to some level, then this area will create a north and south pole at each edge of the crack. So what is happening over here? The magnetic field exits, you can see the magnetic field exits the north pole and re-enters at the south pole. How it occurs, I will show you in the next slide. Right, so just see how magnetic particle test is conducted. One yoke is used in which coil is there, you can see coil is there. When we will pass the current from this particular electric cable, it will generate some electricity. So due to that, these magnetic bars, or you can see these two magnets, will generate magnetic field. So when an electric current passes through the component is over here, you can see, and we have to identify the crack. Okay, so when an electric current passes through the component, then magnetic field come into existence in perpendicular direction. As I was telling earlier, the magnetic field exits the north pole and re-enters at the south pole. So you can see it is coming out from the north pole and goes into south pole, and again it comes out from south pole and goes into north pole. So let's see the new figure. If there is any discontinuity just like this in the material between two poles means north pole and south poles, then another pole, north pole and south pole, comes into existence. That means at this point there will be north pole and this point there will be a south pole. So due to that, lines of magnetic force does not remain continuous. You can see the lines of this magnetic field does not remain continuous. So there will be a leakage of current due to this particular defect. So what do we have to do in this particular test? Iron oxide powder is applied on the component. Then the powder gets accumulated at the place of defect where newer poles are developed. As I said earlier, there will be a north pole and over here there will be a south pole. As the accumulation of powder which will be over here, that will indicate the place of defect. So this test is used to reveal the same on surface and subsurfaces. So you can see the crack is over here, iron particles are sprinkled over here. So due to this void or vacant space, magnetic field lines are discontinuous. So the particle will be attracted towards each other and make a cluster, right? So the cluster of particles indicates that some defects are here. Even if there is a subsurface defect like crack, not at the edge of this particular area, if crack starts from here to this point, it will also detect the crack. Okay, so now we will see some advantages and disadvantages of magnetic particle test. So in advantages, it is very fast, simple and inexpensive. We don't have to spend a lot of money. And second one is direct visible indication on surfaces, right? Then third point, it can be used on painted objects. It doesn't mean that non-painted objects are used to get the defects. We can also apply this test on painted objects. Then surface preparation is not required. That means we don't have to clean its surface, we don't have to grind it, we don't have to rub it, we just let it be as it is. We can check this particular object also. Now disadvantages. It is only good for ferromagnetic materials because only ferromagnetic materials can pass the magnetic fields, so it can be applicable to ferromagnetic materials only. Diamagnetic material will not be applicable to this particular test. Okay, so next, subsurface defects will not always be indicated. So this subsurface defects will not always be indicated. If subsurface defects will be lower than 1.5 centimeter or 2 centimeter, so from this top edge area, if the crack is over here, so it cannot detect that particular crack. Objects must be demagnetized before and after the examination, because whenever this material is magnetized by this particular yoke, it can attract other ferromagnetic materials also, so we have to demagnetize it. Okay, next test is hydraulic test. This test is basically used to inspect pressure vessels. After ascertaining that vessel is defectless, the vessel is filled with water. The name itself says we have to do a hydraulic test. That's why we have to use some liquid or any other things in liquid form. So we are using water over here. So we have to fill this vessel with water fully. A pressure gauge is fitted at the top of the vessel to measure the pressure inside the vessel. Then we have to increase the pressure by a pump and take the reading of the pressure gauge. So this pressure should be maintained or obtained twice than the pressure for which the vessel is to be used. So what will happen if moisture is present at any place around the weld? Basically these pressure vessels are made by welding different components. So if any defect, any crack, any void is present at the welded area, so what will happen due to the pressure of this water, which is maintained at twice than the pressure? So if moisture comes out from that particular area, so we will come to know that there is some crack or any kind of defects. So if moisture at any place around weld is found, then it is the indication of crack or porosity in the weld. This is what hydraulic test is. So till now we have seen few non-destructive tests: visual check, paraffin and white wash test, magnetic particle test, hydraulic test. So rest of the test will be covered in next lecture. Thank you.